Lab 5, Magnetic Molasses by Raymond Mills. In this lab video, I'll be going over the model experiment, the results of that experiment, the closed script model, or the code, and the comparison between this and the closed script model, and the conclusion with the questions. The fundamentals of this lab were Faraday's law, the Biot-Savart law, basic Newtonian physics, Ohm's law, and other derivations of these laws. The preliminary results were the student time was 1.43 seconds, the computer time was 1.598 seconds, and we got the computer time is a little bit more. This is the EMF and magnetic field. For the model was a magnetic dipole falling through a tube of non-ferrous metal, and this was used to simulate Lenz's law. The data and results for this lab was as follows. This is just a little info graphic of the lab, and it was a magnetic dipole, and the average time was 1.43 seconds. Checkpoint. Why can't we use a ferrous tube? And how is this different from a normal drop? So if we were to use a ferrous tube, then that would make the magnet just stick to it, like magnets stick to metal or normal metal, like steel. And if we were to use a ferrous tube, then it would just stick to it and it would just stay there forever. And how is this different from a normal drop? Well, if we were to drop it in open air, it wouldn't be able to induce currents in anything. So it would just fall like any object would. But since it's in the aluminum foil and produces eddy currents, it kind of locks it there, or tries to lock it there. The code for this lab is here, and this code was just used to calculate the two graphs as seen here and here, and those just illustrate the magnet's tendencies, like through the program, not in real life. The comparison, why was the calculated model slower? The calculated model was slower because our magnet was definitely not ideal, the aluminum foil was not ideal, and everything wasn't perfect, because that's what the model wants. It wants everything to be perfect, and it'll never be the same as the model in any lab. And the discussion: what if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the following magnet change? And what if holes or slots were cut into the tube? How would this affect the ring currents in your model? Okay, so for the first question, the magnet would just stay in place like it does with ferrous metals. It would just lock itself there and just stay there. But that wouldn't happen. It can't happen because nothing will ever have zero resistance, because that would definitely break some laws of energy and stuff. And for this second question, what if holes or slots were cut into the tube, and how would that affect the ring currents in the model? Well, it wouldn't really do much. It might just make the magnet spin more. The ring currents wouldn't really mind it at all. And thank you.